So now in this video, we're going to look at a non-inverting comparator circuit using an op amp. So I'll explain what that all means coming up. We're using the LM358 right there. And it's got two op amps, but we're only using the one on the left. And the output's on top, that jumper there. The inverting input is right below it. We have two equal value resistors giving us a reference voltage. And so it's going to compare that voltage with the non-inverting input. So that's down there. That's the trim pot. It's an adjustable voltage. And, you know, it's just really intended for this demonstration circuit. Hopefully you know about trim pots. You can get basically the 5 volts right there. You can get 0 volts down there or anywhere in between. Somewhere right at about 2.5 volts, we have a high enough voltage here because it's higher than that one to set the output high. And you know, that's half of the supply voltage, about 2.5 volts. So if we set the trim pot a little bit below or all the way below, doesn't matter, the 2.5 spot will have a low output. So you can see here that high, well right now it's low, so it's connected to ground as good as it can. You know, not perfectly, it goes through transistors and stuff, so it won't be exact 0 voltage there with this, you know, pulling the voltage up a little bit. And now we have a high output, so that means we're as close to the positive supply. This one is going to be doing worse, but you know, like 4 volts or so is coming at the output. Red LED is lit up, so with the 220 ohm resistor, we got somewhere about 7 milliamps of current, and I'll set the output low. It has a higher resistor, 1000 ohm resistor, and so you know, at this lower current, it connects to ground better than it would if we had more current going through. But in any case, we do expect about 2 milliamps of current through this 1000 ohm resistor. Blue LEDs are just naturally brighter, even though it has about 1/3 of the current, not even that, going through it as the red one does. It's you know, a really bright component right there. So now, some other things to keep in mind whenever you're using an op amp is that the inputs don't let current in or out. If they did, then especially with the resistive components, they would alter the voltage. So in this case, we got a fixed half of the supply voltage right there. If you know, the input headed to ground at some point, current was getting through and headed to ground, it would pull that voltage down below 2.5 volts. Whereas if it for some reason headed towards the positive supply through the transistors or whatever inside there, then it would raise the voltage above 2.5 volts. So you want your op amps to have high impedance. Some of them have higher than others, but typically they're all very high. So be aware that if you need a super high impedance op amp, you may have to find a different part number than this one. Just be aware of that. But yeah, the trim pot, you know, if it did leak some current again, this is an adjustable voltage. But again, it would throw voltage off, either pulling it up or down if it was going through there. So you don't want any current to go through the inputs right there. And we have a 10K trim pot right here. If I set it halfway, that's 5,000 towards the positive supply, 5,000 towards the negative supply. This is 10,000 to the positive supply, 10,000 to the negative supply. Doesn't matter. As we said before, current's not going through or out, so it's just the position right there. So we don't have to use 10K there. We could use a 100K trim pot over here. It doesn't matter. We'll get the same results out here. We got half the supply voltage as long as those are equal value resistors, and we can get any voltage up to 5 volts or 0 volts in this particular circuit. So now we'll actually look at voltages. So just got to set this to V right there. It's auto ranging. It does the rest. And don't have to move the red probe for anything than high current for this particular meter right there. I have these alligator clips that I crimp to jumpers. So I can clip the probe and then plug the jumper into the board, the other end of the jumper right there. And we can measure the voltage. I should probably do the ground one first. Our voltage is going to be in relationship, that's not the one with the alligator clip, there it is. You know, that's the jumper that I used right there, just male on both ends, and I clamped that on with a pair of pliers. So yeah, we'll plug that in, and our voltages are in relationship to ground that we are interested in. And first we can look at the output. As I mentioned before, we do not get to the supply rails, especially with a load right there. So there, that looks like we got to 0 volts. Somehow we got a negative. That's kind of interesting. Again, there's transistors in there and stuff. Who knows? Oh, this also pulls it down. So I really can't explain how we got a negative voltage right there. So, in any case, but yeah, we hit 0 volts. That was the main thing. With the output, with no load, you can see the load is lifting up the voltage because it comes from the positive supply, as I said before. Now, high output, there you can see 3.4. So, I'm not surprised it's 1.5 volts less than the positive supply rail because of how much current we're providing, about 7 milliamps. According to the power supply, it's not as accurate as a multimeter, but it's going to be close. But there you can see, it goes up a bit without the load right there, but it still falls, you know, somewhat short of the 5 volts. And since I removed the LED, plus we weren't getting a lot of current anyways, you can see as I raise the voltage, it's going to, you know, fall short. We got 7 volts, and right now at the output is 5.7 volts, so about a volt, 1.2, maybe 1.3 volts short with no load, and then it goes down a little bit more with the load. So something to be aware of. Always learn about the output limitations of the op amp that you are using, and some have more than others, and what so on. So, some of them cannot get to ground even without a load. This one can because it's a single supply. So, just be aware of that. And yeah, we can look at our reference voltage right there. That is 2.545 it says. And, you know, it may kind of shift a little for whatever reason, but pretty rock solid right there. Hardly any change at all. And of course the trim pot, there's really no good spot to plug it in right there. I guess that would work pretty good. But we got 1.120 should be the exact same right there. And because you know, no current's flowing in or out of the input right there. So there, you can go to 0 volts, go up to 5 volts right there. And I do have the power supply set to 5.1, just because at 5 volts now it would say like 4.9 something, or 99 something, or something like that. So raise it up just a little bit so that we got resistance where the connectors are and stuff. They'll drop a little bit of voltage, which relates to what I was saying earlier. This input's not letting current through right there. So we're at a standstill with the current, but the voltage still transfers over here, and we can measure that voltage. So as long as no current's flowing, it's just built up that voltage there, we'll get an accurate reading, even though we got the jumper. No current's flowing through, so there's no drop. So, in any case, yeah, that's really about it. It's a pretty simple topic, so I mentioned some extra stuff, so I hope you enjoyed. But yeah, that's it. Thanks for watching. Make sure you check out one of the other videos I'm posting on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.